Let us move on to quantitative data. As with categorical data, we can construct relative frequency and percent frequency distributions. And there are also several ways to construct charts showing quantitative data. Let's look at one example. Suppose, for instance, Hudson Auto Repair. It's an auto repair shop, and the manager would like to understand the cost of parts used in the engine tune-ups that they do in the shops. So what the manager does is she examines 50 customer invoices, and she lists the cost of parts for each of the 50 jobs done. And these are the raw data. As you can see, there are 50 data points, i.e. 50 observations. Again, if we just look at the table, it's not going to be very useful because it's not organized, and therefore it's going to be hard for us to obtain the insights that we need to analyze the costs of jobs at the Hudson Auto Repair. So what we can do is we can construct a table that groups these data into several categories. But in this case, instead of qualitative categories like poor or above average, what we can do is construct groups with numbers that are close to each other. So what we first have to do is we have to construct so-called non-overlapping classes. Then we have to decide how big each class is, and then we have to determine the upper and lower number for each class. Let's do this concretely. Usually the guideline is to use between 5 and 20 classes. If you have a data set of, say, 10,000 data points, you'll probably use like 20 classes. But in this case, where we have only 50 observations, 5 classes will probably suffice. So the general observations, smaller data sets, usually require fewer classes. You want to have just enough classes to show the variation, but not so many classes that there are only 1 or 2 observations per every class. And how do we determine what the width of each class will be? We should make each class the same width, so that once we've determined the number of classes, we then use that as the denominator for this equation, where the numerator is take the largest data value and subtract from it the smallest data value. Then we divide by the number of classes. Let's go back to the slide and please determine for yourself what the largest and smallest values are by inspection. From my inspection, I think the largest number is 109 and the lowest number is 52. Let us keep these numbers in mind. That's right, the approximate class width is therefore 9.5, which we can round up to 10. How did we get that? 109 is the largest observation, 52 is the smallest observation. Let's say we use 6 classes. 109 minus 52 divided by 6 is equal to 10. So what we should do is make each width equal to 10 observations. So for instance, look at 50 to 59. That's 10 observations. Same thing with 60 to 69 and so on. Okay. Then what we do is we tally. There are 2 observations that are between 50 and 59. Let's go back. 2 observations between 50 and 59. Yes, there is 52 and there is 57, and I don't see any other numbers in that class. Right? So you can do that for each class, making sure to correctly tally, and you will get to all these observations. So there are 7 observations that are between 90 and 99 and so on, and the total should be equal to 50. Let's deal with some final recommendations and observations. So each data item should belong to one and only one class, and that's why you shouldn't have overlapping numbers. You cannot have 50 to 59 and then 58 to 69 or something like that. because the number 59 would now appear in both the first class and the second class. Each data point should appear in only one class. The lowest class limit would identify the smallest possible value. What is our lowest class limit? 50 to 59, right? And 52 is the lowest possible. And similarly, the upper class limit will identify the largest possible data value. So, please consider this table. We know the number of observations for each class. Following the same logic we use for the categorical data, we can therefore construct relative and percent frequencies, right? All you do is, let's go back. For the first class, for instance, 2 divided by 50 is 0.04 or 4%. Please keep those two numbers in mind. As you will see in the first column, the first class, its relative frequency is 0.04 and its percent frequency is 4. Obviously, if you add these all up, they should add up to 1 and 100% respectively. Do you know why we got 0.14 for this class, 90 to 99? Why we have 0.14 and 14? Let's go back. That's just going to be 7 divided by 50, which is 0.14 or 14%. Now, what insights can we gain from that table? Only 4% of the parts are in the $50 to $59 class. 30% are under 70. How do we get that? Let's go back. Under 70 would be class 1 and class 2. Look at the percentages, 4 and 26, which is 30. Hence, 30% cost under $70. What is the class with the most number of observations? It would be in the class 70 to 79. Let's see that. 70 to 79, 32% of observations are found in that class. That is the highest percent frequency. And finally, only 10% of the parts cost $100 or more.